now let's see one more derivation, which is about effect of latitude. This derivation is about the variation of acceleration due to gravity with latitude. So in this, first of all, we'll understand like what is latitude. So like if I consider that this is the Earth, I say this is the geographical axis, and this is the central geographic equator, central line dividing Earth into two hemispheres. So this is the equatorial, becomes our equatorial plane. And that O is the center of Earth. Okay. So if I join this, OE becomes the radius of Earth. And there is a point P located on the surface of Earth. There is a point P located on the surface of Earth. So see, latitude at a place, it is defined as the angle which is made by the line joining the place to the center of Earth. This line makes an angle with the equatorial plane. That angle represented by lambda is called the latitude. So you can see that our angle POE, which is equal to lambda, is the latitude, right? Now, if I consider like Earth to be a perfect sphere, so let us consider that like Earth is a perfect sphere of mass, and this is the geographical axis. O is the center of Earth. Okay. So capital M is taken as the mass of Earth. Capital R is taken as the radius of Earth. Capital R is taken as the radius of Earth, and O is taken as the center of Earth. So the whole mass of the Earth can be supposed to be concentrated at the center of the Earth. So when the Earth is rotating about its polar axis, this is the geographical north, this is the geographical south, and the Earth is rotating from west to east, then all the particles on its surface, so if I consider, okay, there is a particle P present over here, so all these particles, they are moving in a circular path. So this particle is moving in a circular path. So I'm describing a circle. C is the center. So this is having this circular path is having a radius small r. Okay. Remember that capital R here is the radius of Earth. You can say radius of Earth is, if I join O with P, OP is equal to capital R is the radius of Earth. And the angle which this line joining this place with the center of Earth makes with our equatorial plane, this angle is lambda, our angle of latitude. So if this angle is lambda, then geometrically we can easily infer that this angle CPO will also be equal to lambda. Angle CPO will also be equal to lambda, right? And so we can easily say that small r here, which is equal to PC, will be equal to OP cos lambda. And OP is equal to capital R, so this becomes small r is equal to R cos lambda. Small r is equal to capital R cos lambda. Now, when the particle is present at point P, there is a gravitational pull acting on it. gravitational pull acting on it represented by mg, that is acting towards the center of Earth. And at the same time, there is a centrifugal force also. So the particle is experiencing a centrifugal force also in the outward direction. So suppose this is acting along PA, and this centrifugal force is mr omega square. So mg is acting towards the center and mr omega square is acting in the outward direction. So if I just complete this parallelogram, I try to find out the resultant of these two forces. So the resultant force is acting like this along PB, and this resultant force, I'm just calling it as mg dash. This resultant force I am calling it as mg dash. Okay. So we have two forces, mg and mr omega square. So by using parallelogram law, we can find the resultant of this. So mg dash here is the resultant of these two forces. So I can say that mg dash is equal to, by using parallelogram law, this is equal to under root of mg square plus mr omega square whole square plus twice of mg multiplied by mr omega square into cos. Now what is the angle between mg and mr omega square? What is the angle between mg and mr omega square? The outer angle is lambda. Angle CPO is lambda. So it is angle OPA. This is the required angle between mg and mr omega square. So this angle will be 180 degree minus lambda. So here I will have to take this angle. So cos 180 degree minus lambda. Okay. So I am putting all of this in square root. Right. So we can take m common from this outside the square root, and it gets cancelled on both sides. So what we are left with is g dash is equal to under root of g square plus r square omega raised to the power 4 plus twice of g r omega square. Now cos 180 degree minus lambda is cos lambda. So I can put it as cos lambda only. And we are putting all of this in the square root sign. Right. Now since we know that small r is equal to capital R cos lambda, so if I put this in this equation, so what we are left with is, I'll just write it on the next page. So what we are obtaining is g dash is equal to under root of g square plus capital R square cos square lambda omega raised to the power 4 minus 2 g capital R cos lambda omega square cos lambda. All of this is in the square root sign. Okay. And I can take here small g also outside. So if I take small g outside, so this g square we get 1 plus r square into omega raised to the power 4. Now we were not having g square over here, so I have to put g square in the denominator into cos square lambda, right, minus 2 capital R omega square into cos lambda will give you cos square lambda, okay, divided by g, and for under root I am putting raised to the power half. Now if I look at this figure, r square omega square by g, because this is r square omega 4 upon g square. Now if I look at r omega square divided by g, all these quantities, they are constant quantities. If I put their values, like capital R is the radius of Earth, which is 6.4 into 10 raised to the power 6 meter, multiplied by omega is 2 pi by capital T. So 2 pi by capital T is the time period of rotation of Earth. So time period of rotation of Earth is 24 hours. In 1 hour we have 60 minutes, and in 1 minute we have 60 seconds. So I have converted into seconds, and if I square it, okay, multiplied by 1 upon, so G here is 9.8. Okay. Now if I try to find out its value, it will be very small. It will be 1 upon 289. 1 upon 289. So since R omega square by G is very small, so we can neglect this R square omega raised to the 4 upon G square in this equation. So if I neglect this second term, so what I have got is G dash is equal to G into 1 minus, so I will write this to R, 1 minus 2 R omega square upon G into cos square lambda raised to the power half. So I'm left with this. And we can expand this equation binomially. So if I expand this equation binomially, what I get is G dash is equal to G into 1 minus, this 1 by 2 will come down, 1 by 2 into 2 R omega square divided by G into cos square lambda. Okay. So remember that when we are expanding something binomially, so if I have 1 plus x raised to the power n, where x is very small as compared to 1, so it can be written as 1 plus nx. So actually there is a whole term, whole series, binomial series, 1 plus nx plus n into n minus 1 upon 2 factorial into x square plus n into n minus 1 into n minus 2 upon 3 factorial to x cube. So since x is very small, x square, x cube will be still smaller, so they can be neglected. So what we are left with is just 1 plus nx. So n power will come down. Okay, so now this 2 gets cancelled. So what we are left with is G dash is equal to G into 1 minus R omega square cos square lambda divided by G. We are left with this. Okay, and if I take G inside, so what we obtain G dash is equal to G minus R omega square cos square lambda. So we are left with this. G dash is equal to G minus R omega square cos square lambda. This is our expression. So since cos lambda and omega, both of them are positive, so you can say that here G dash will be less than G. Okay, so that means the acceleration due to gravity is going to decrease because of the rotation of Earth, and it is also going to decrease with the increase in the value of the latitude of the place, means lambda. So now if we look at this equation more closely, we have derived this relation that G dash is equal to G minus R omega square cos square lambda. We derived this relation. So when you are at equator, you know that lambda is equal to 0 degree. That the acceleration due to gravity G dash at equator is GE. So acceleration due to gravity at equator GE will be equal to G minus R omega square, because this cos 0 degree will be equal to 1. And remember that this is the minimum value of the acceleration due to gravity, because we are subtracting R omega square from G. And when you are at pole, lambda here is taken as 90 degree. Okay, and you know that cos 90 degree will be equal to 0. So G dash, which is equal to GP, will just be equal to small g. This is the maximum value of acceleration due to gravity. So that means when you are present at the pole, the value of acceleration due to gravity is maximum, And from pole, when you move towards equator, the value of acceleration due to gravity is going to decrease. Okay, so what is the difference in the acceleration due to gravity when you move from pole to equator? That means what is Gp minus Ge? So we know that Gp minus Ge will be equal to, the Gp is G minus Ge is G minus R omega square. So you can say that here the difference is of R omega square. So if there is a man of mass m which is moving from say like equator to pole, then if he is moving from equator to pole, G is increasing. So his weight will also increase, and the weight will increase by mr omega square. Okay. And if we calculate this value of R omega square, so Gp minus Ge, we know that this is equal to R omega square. The value of capital R radius of earth is 6.4 into 10 raised to the 6 meter multiplied by omega is 2 pi by capital T. So 2 pi divided by capital T is 24 hours into 60 minutes into 60 seconds. And this whole is squared. So we get approximately 0.034 meter per second square. So the value of acceleration due to gravity is going to vary by 0.034 meter per second square when you move from pole to equator. Of course, this is quite small, so that's why we take approximately 9.8 meter per second square on surface of Earth. Okay, I hope this is clear to you.